Hey everyone, how are you doing? Here's a quick video for week 1 Desmos activity from my Algebra 2B students on how to get started and what this activity looked like. So in this week 1, we're exploring exponential functions and starting to dig into a little bit of logarithms. But for this week 1 Desmos activity, we're going to use exponential functions to model growth and decay. So here we are, we're on the first screen, and it gets into when I was your age, what were movie ticket prices? So the first thing you do is going to just predict, it could be right, it could be wrong, you're going to predict how much you think a movie ticket cost in 1948. I'm just going to say 50 cents. Share with the class, and we'll move on to the next slide. Now, one way to make more accurate predictions is to start thinking about the relationships. Now we're getting into a function between ticket price and time. You're supposed to sketch what you think the ticket price versus years before 2018. One thing that's confusing is, notice this bottom column is years before 2018. So technically the zero part would be right now, 2018, and the farther you go to the right would be how many years before. So this might be like 10 years before, 20 years before, 30 years before, 40 years, 50 years, or sort of. So right now, the ticket is the most expensive, but if I look back in time, I would probably say something like this. Well, right now it's like 13 bucks, but if I go back in time, it was less, and less, and it was cheaper, maybe only $1 or $2 back before 2018. So I'm just gonna make up a guess, something like that. Definitely put your thinking below, put your prompts in, follow this stuff. I do look at your answers to see your thinking on these activities as well. All right, on the third slide, so now you're going to start building a model. Now we're going to start using some algebra. We've done linear equations and quadratic equations in the first semester. Now we're getting more into exponential. And so now we're going to say, well, drag the red point. So we're going to do an exponential function. And here's where I'm going to tweak around, and I want to make a function that seems to fit these points as best as possible. You're welcome to try and do a linear one or a quadratic one. I'm going to do an exponential one. I'm going to call that pretty good. There's my model that fits the 3 data points that I have, and I've now got a mathematical model. And the model you built on screen 3 is shown in red, and it's giving me the actual exponential function. 9.68 is my starting value. 0.97 is what I'm multiplying by over and over and over and over again. So I'm going to go and pause there. I don't want to do the whole activity for you, but you're going to dig more into how does this model fit our data point? What does this point 9.68 mean? What does this point 0.97 mean? Think about in terms of exponential growth or decay. And now that we have a model, we can actually make predictions. Look at, there's my estimate down there. I'm going to make a new prediction that in 1948, which is 70 years ago, according to my model, it's more like $1.10. So my mathematical model is showing me at this point right here, which is higher than my initial guess. All right, hopefully that gets you started and gets you thinking about how we can use exponential curves, whether it's growth or decay, to model certain types of problems.